Professional engineer, national exams, December 2019, 16 CIV A1 elementary structural analysis, 3 hours duration. Professional engineer, national exams, December 2019, 16 CIV A1 elementary structural analysis, 3 hours duration. So these are notes for the candidate. You can go through. This is question 1, question 2, question 3, question 4, question 5A and 5B, 6, question 6, question 7, question 8. Okay, now we will try to solve question 2A. Okay, in this question, for each structure shown, compute the reaction and draw shear and bending moment diagrams. Indicate which are positive and which are negative segments of each bending diagram. For each shear and bending moment diagram, calculate and indicate the magnitudes of the maximum positive and negative ordinates. Okay, so the first thing is to compute the reactions for this structure. Now, I'll split at this internal hinge. So we have one hinge, one roller, two rollers. So we have one hinge, two rollers, and internal hinge. This is called internal hinge. How can I analyze this one? Okay, if I call this one R1, R2, and R3. So if I split at this hinge, so it will be here R1. Okay, and here it is 36 kilonewton. This one is reaction. F, call it F. This is the hinge. This is this hinge. So now F, how can I compute F? How can I compute F? We can compute F like this. Sigma moment about this point, which is called, I call it point 1, equal to 0. Sigma M1 equal, about M1 equal to 0. So F multiplied by 3 meters. F multiplied by 3 equals to 36 multiplied by 1, from which we can conclude that F equals 12 kilonewton. So F here, it is 12 kilonewton. Okay, now I'll go to the left-hand side portion of this structure. So it is here. You see, here is the internal hinge, here is the roller, and R2 is here. Okay, R3 is here, and this is the uniformly distributed load, which is 8 kilonewton per meter. And these distances are, this is 1, this is 6 meter, and this is 1 meter. Okay, and here at this hinge there is a force 12. So this in this part, or in this portion on the right, it is 12 downward. So I have to put it 12 upward. It must be in opposite direction. So it is like this. Now, taking the moment, about 0.3, about this hinge, then equal to 0, and I'll assume everything in clockwise is positive and any moment anti-clockwise is negative. So now 8 multiplied by 8 multiplied by this distance, the centroid of this uniformly distributed load, it is here. So the distance is 3. It is clockwise. Here 12 is anti-clockwise. So it is 12 multiplied by the distance, 1 plus 6, it is 7. Okay, and then this one also is minus because it is anti-clockwise, so it is R2 multiplied by 6 equal to 0. This gives R2 equals 18 kilonewton. Okay, so I have computed 18 kilonewton. R3 can be computed from sigma Fy equal to 0. Everything is positive. So R3 plus R2 minus 12 or plus 12 minus this uniformly distributed, it is 8 multiplied by 8 equal to 0. Now R2 is 18, so I can just plug in the value 18 here. Then from this equation, I'll get R3 equals 34 kilonewton. So I have computed R2 and R3. R1 here is also maybe computed by sigma Fy equal to 0, and everything up is positive. So R1 minus 12 negative minus 36 equal to 0, from which R1 equals 48 kilonewton. Okay, so now I have computed R1, R2, R3. The next step is, so I computed the reaction. So the next step is to draw the shear and bending moment diagrams.